I'm Claudia Löbel, and I'm an assistant professor in material science and engineering here at the University of Michigan. And my lab is excited about biomaterials, and in particular biomaterials for regenerative medicine applications. You can all appreciate that our tissues have a very different healing capacity. For example, skin heals very well after an injury, while other tissues, such as our brains, they have a very low capacity to heal. And we are interested in understanding why and how these tissues regenerate, and in particular in understanding how the lungs regenerate small injuries, injuries that can happen every day when we inhale dust or small particles.
I think materials is everything. Like, you cannot do anything without materials, and right now I think the world needs more people working on materials that lie at the very horizon of biology, as well as like focusing more on clinical perspectives, which the Global Lab is doing. I'm trying to reproduce the tissue architecture of the bronchi, which are the airways leading to the lungs, and this falls in line with the pulmonary research that goes on in other projects inside our lab. And I'm trying to reproduce these very wavy-like patterns that are already there inside our body. So that is my work, yeah.
To solve the problem of better understanding how our lungs regenerate these small injuries, we recreate aspects, we engineer aspects of our lung tissues in a dish, which means outside the body in our labs. And to do so, we culture mini lungs, which are also called organoids. And in particular, we're using biomaterials, such as hydrogels, to have a better control over the culture and the maintenance of these organoids, these mini lungs in a dish.
So I've been working in the Löbel Lab for a year now, and I've been working with mini organs in a dish, or organoids, specifically lung organoids. And my work centers around the biomaterials that we use to grow these organoids on top of, but they can also just be used for culture in general. And the reason why we're working with biomaterials is so we can have a very defined environment in which to grow these organoids, because currently the methods are very heterogeneous and produce a lot of variability in the organoids. So yeah, we're working to engineer these materials and get consistent results. It was actually just last week. I've been working on like more of the material side, less of the biology during the school year, but then I've started to culture the organoids. So last week I got some really cool images from the microscope of the organoids that I got to grow. So they look really good. Yeah.
Growing these organoids in a dish, as you may expect, requires a diverse set of expertises. And I believe this makes my lab unique within the material science and engineering department because we have a diversity of trainees and people in the lab with different backgrounds from engineering, material science, as well as biologists. And we have many collaborations with clinicians as well as biologists because these mini organs, these organoids, are very useful towards better understanding the biology as well as testing or developing new drugs.
First of all, the Global Lab is very collaborative in terms of its projects, and we work with other labs all the time. And apart from that, this is a very fun lab as well. We do go out on very like picnics and stuff like that. We are even going kayaking the next weekend. So we are a very social group as well, and we even play volleyball with other labs. So it's a very fun lab. It's fun working here, and Professor Löbel is also very welcome to new students, and she supports us very well.
We are a young group within the material science and engineering department. However, we are committed to creating a group culture where every voice is heard and respected. Because we do believe that if people feel respected, they can be more creative and they can be more successful.